All right, so the graph below shows the value in dollars of compound interest. So what we want to do is they're always going to tell you what you're dealing with. So here we've got compound interest. So on your formula sheet, you go and look, and I've found the part that says compound interest, and I've just taken a little bit of it. Okay, so, and it says, so this shows you the value of an investment, compounding periods VN for a period of time over there. So you don't actually know what the periods of time are, but that doesn't matter, and you've got the value of the thing. So you've got this graph, and obviously compound interest is a curved graph, so you can see it's a curved graph anyway. So it's got the coordinates where n equals 2, so this is up here, and they want you to find B. So B is the value of the investment at 2 periods, time periods, yeah? So we've got that. All right, so then we've got to look at what we've got to do. So when you have compound interest, you can use all that compound interest, anything like that, or, reducing balance, you can use Finance Solver. So what I suggest is we're going to look at that. Now, when you have 0 periods, if you have 0 periods, that means that this is obviously your initial value. So in terms of Finance Solver, that's your PV. So I know, and if you look at it, so if you look down here at the compound interest formula, if I wanted to use, this is the Nth Term Formula. Okay, so that means, and I obviously want V2 is my question. But you can look here, I don't know, see how the formula, you've got to use that R, but I don't know what that is. And so here's how you find out R, but I don't know that. So I'm going, but I don't have all that information, so I'm going to go and use Finance Solver because I do have some scenarios up here or along the way. So you could use any one. See how we've got all these scenarios? We could use any one to find out what that interest rate is because we don't know what's happening. So what I'm going to do is use Finance Solver. So I'm going to pick this one here. Okay, and what I go, so N, it means I can see N was after one compounding period, yeah? And the interest rate is what I don't know. So in Finance Solver, when I go to find it, I'm going to look at that. Now, PV, I know. Now, when you invest, remember invest, so you're giving the money to bank, that means it is, it's a sad day. So it's negative, okay? When your money goes away from your hands, negative, okay? So that's negative 500, and I got that from that start of the graph because they said 0 periods. Now, payments, they've mentioned no payments, so we'll just make that 0. That's fine. Now, FE, I know the value after that 1 period is 580. Now, it's going to be positive because it's an investment. It'd be like if I'm taking it back to me, it would be positive. So that one's positive. And now the PPY is how many times per year that it gets. Now we don't know whether this is monthly, yearly. All we need to do is we can just write the 1. We can pretend it's yearly because as long as we pretend every 2, 3, 4 along the bottom there is yearly, that's fine. So we'll just make it 1. So into the calculator, we're going to do that and let's find out. So we're going to find out what this is. I'm just going to pause it. Okay, so we've popped that into finance and we've found that it's 16. So now our next step is we want to find when n is 2 and we now know that the interest rate is 16. We still leave the PV at negative 500. We're still making payments 0 and the FE is actually what we wanted to know. That's the question, that's B. Yeah, and we'll leave PPY as 1 and we press enter on our calculator and we get 672.80. So there's the answer there. Okay, so consider the following amortization table for a reducing balance loan. So always good to pop that in reducing balance loan. And if you have a look, we've got these amortization tables. These ones as well, I would think should go in your reference book. So they said the annual interest rate down here is 3.6. So in terms of, they actually gave the per annum rate, which is what we often refer to as our little r. And that's generally what they give. Now they said interest is calculated immediately before each payment. They will write that statement every time. You don't have to worry about it because, you know, people could debate, you know, if you charge interest at a different point. So they'll put that statement. It doesn't really mean much to you. They just have to put it in there. So for this loan, the repayments are made. So what they don't know whether they want to know what these repayments are. They weekly, are they monthly, and that we don't know because we can't see. They only told us that it was 3.6 per annum. So what I'm going to do, and this is often good to have this in your book, is I'm going to use this here, interest. So I'm going to use that interest to find, because I know that's been calculated, to find the interest, you know, what the interest rate or how often it's being done. Now, when you have an amortization table, the interest amount, so you can see this is the interest amount, you can use this formula. What it was you used the rate and you times it by, so this 900 was times by the rate, to find it, it was the rate times the balance before. So there. So I'm going to use this formula and set up a solving situation. So what I'm going to do is I know that the interest amount was 900 and it would have equaled the rate times the balance before, which is 300,000. So how do we find that rate is what we do. If you look, the rate is found by doing the per annum rate divided by PPY. Now, PPY, that is the question. That's what they're asking you. They're asking you how many times per year is this amortized, is this account showing, or the reducing balance loan. So if I pop that into here, so if I do 900 equals, now the R is always the rate per annum, so it's 3.6. Now I'm going to just let this PPY equal X, so on my calculator. So I'll just put X, and then I've got over 100, and then I would have times it by 300,000. Okay, once I've got that set up, I can just go solve and comma X. And we'll end up thinking that X equals 12. So therefore I'm saying PPY equals 12. So what does that mean? That means it is monthly. And that's where we get that. Okay, so a machine is purchased for 30,000. It produces 24,000 items each year. The value of the machine depreciates using unit cost method. So here is the unit cost method. This is important for you because you need to go and get the unit cost method things. It says after 3 years, the value of the machine is this. The rule for the value machine after nth units is used. So really, what they want is the, this is called the nth term formula. So what I'm going to show you is you're going to go into your sheet. Now we want, this was unit cost depreciation. So can you see we've got this, I've got unit cost there. This is what I'm looking at. So I'm just going to drop it in here for you. All right. So here, unit cost method, matched it up. Now, on this formula sheet, this column is the recurrence formula column. So all the recurrence formulas go down here. And in this column is the nth term formula. So you can see here, this is how I find out nth term, okay? So I'm going to go fill this in. Now, the nth term equals Vn. Now, it equals VO. So what I'm looking for now is VO. So how much was the original machine worth? 30,000. Yeah, good. So we're going to write, all right, we know that part. So I pop that in. So that's 30,000 minus, now N times, now because that D is highlighted in pink, I need to work out what it is, like, I need to put that into the formula. So I look over here, this is the amount depreciated per period divided by the number of uses. So if I go and I'm going to work that out, the amount it depreciated. So we have been given, we could work this out because we have the 3 years mark, okay? So it's now worth that. So how much did it depreciate? It went from 30,000 down to 18,480. So that's going to give you how much it depreciated. Okay, so we know this is how much it depreciated. So D after 3 years. So then we knew we're going to divide by the uses. It was 24,000. Now I end up with 0.16. So really what that's saying is it's like 16 cents per copy. Okay, so we can tidy up this formula now. Really, I would just write Vn equals 30,000. And we often write the letter N after the number, okay? Now, can we see that option in our selection? Yeah, it's E, isn't it? Okay, and there we go. We've got the answer. Okay, so Joseph borrowed 50,000 to buy a new car. Interest on this loan is charged at 7.5% per annum, compounding monthly. Okay, so here you're starting to get, and when you get later on in the exam, you get these, you'd be using Finance Solver, yeah? So I'm going to start thinking. So he borrowed 50,000. So this is a loan, but the bank gave him that money, so that's a positive PV. It came into his hands, so he could go buy the car. So the interest was charged at 7.5% per annum. They will always give you per annum. So on Finance Solver, that's I, because you have to have the per annum. And then this compound monthly, that tells you PPY equals 12. All right, Joseph will fully repay the loan with 60 monthly payments. So that, remember, it ends like the monthly, so over 5 years. Okay, so that makes sense. 5 times 12 is 60, so there'd be 60 monthly payments. Immediately after the 59th payment is made, Joseph still owes 995.49. For the value of the final repayment to the nearest cents will be. So what happens is, even though see how we need to, firstly, we need to know he still owes that much and what will his final repayment be. So we probably need to first know what it will do. So let's have a look. So I'm going to go through Finance Solver and I'm going to find out what his payments actually are. So let's go through this. So I've got 12 times, 5 years he's going to pay this off. The interest rate is 7.5. PV was 50,000. The payment is what I want to know. Okay. And FV, because he was paying that loan off after the 5 years, he wants it 0. And PPY is 12. So let's find out what his actual payments were. And what happens is the last one is, a little bit off, so we have to adjust it. But let's see what it would have been. Okay, so if we go do that on Finance. All right, so I do that and I get that his payments are 1,101.89. Okay, now if I rounded that up, so if I round that up to 90, I'm going to say, that's what his payments are. Okay, so what we want to know is if I change it and I'm going to now find out what would his value be if we actually did those payments. So I'm going to say, I'm going to do those 60 payments at 7.5, act like I'm borrowing this much money, 50,000. I'm going to now put the payments in as negative 1,001.90. What we're going to do is we're going to check what he owes his final value when he does that, because his it's going to have to be adjusted. So let's have a look at that. So into Finance Solver, put all those things. Okay, so when we do that, we get this positive value here of, I'm going to say 0.19. So when that final value is a positive, that means the bank owes you. So we get this 0.19. So that means the bank owes you. So after that 60 payments that you've done, your loan, actually the bank needs to give you back something. So they don't want to do that. So what they'll do is they adjust your last payment. So therefore, your last payment, they'll say, no, we don't want to owe you. Just make your last payment can be the 1,001.90 minus that 19 cents. Yeah? Because you still have to pay interest on that last payment. You know, the last little bit of amount. And that's why I like to go over. Some people they stop at 59, but then you're not getting the interest on it. So let's do that. So what would that be? So do we get this answer? Yeah? We get the 1,001.71. Okay, Millie invested 20,000 into her bank with an interest compounding monthly. So once you see this compounding monthly, start writing the things like, so we know when it's compounding, we can use Finance Solver. So I start popping these in. If you're investing, sad day, you're giving your money to the bank, so it's negative PV. After 1 year, the balance is of the account. So try to start thinking, remember that 1 year, N equals 12 because it's monthly, yeah? You know that the final value is this, 2732. That's what this bit just told you. Okay, the difference between the rate of interest per annum used by the bank and the effective annual rate interest for Millie's investment is. So what you need to know for effective interest rate, remember we use in our calculator, we use EFF. We actually put the per annum rate, whatever it is, then we go comma, PPY is 12. Okay, on Finance Solver, this per annum rate is called I. We put the per annum rate into it. So let's go, we need to know what we need the effective and we need the per annum rate to be able to see the difference. So I'm going to use Finance Solver to find out what my I is, because I've got everything I think I need. I've got the scenario when N is 12. This is obviously my question I'm trying to find. So that means I know I can get everything else. So PV, yeah, I've got that, negative 20,000. The payments, she's making no payments. They didn't state it, so we'll put 0. Now, I know after the final value after 1 year, which would be 12, that we had 2732. That would mean the bank has to give it back to her, so it's positive. And PPY is 12. So pop that into your finance. Okay, so I've just done that, and in here I get, and it's pretty much 3.6. Yeah, there's lots of zeros, so I'm going to say 3.6. Is everyone get that? Yes? So over here now, I'm going to work out my effective interest rate. So EFF into the calculator, 3.6, comma 12, okay? And I'll find out the effective interest rate. So I get the effective interest rate to equal 3.6 0.66, okay? They actually want the difference. So the difference will be 3.66 minus 3.6. So we get 0.06% is the difference, and that's how I get the answer. So Ray deposits 5,000 into an investment account, earning interest at a rate of 3% per annum, compounding quarterly. So straight away, once I see it's compounding, I go back and I'm going to start changing this so I'm going to think of finance solver. So he invests, okay, PV, 3% per annum, that's I, or little r, and compounding quarterly, so PPY equals 4. Now, the rule for the balance Rn in dollars after n years is given by. So this is what it's doing, is it's actually asking me for the nth term, and this is a compound interest investment. So let's go into our formula sheet, and we're going to go look, and down here is compound interest. Oops, here. I found compound interest. So I'm just dropping this in here so you can see what I'm using. Now, it's asking me for the nth term. Remember, this column is the nth term. So I need to write the formula. Now, they're not using V, they're just using R. Same thing, let's go. So for me, Rn equals, now, I see here, I need this R. This R, and it shows you how to work that out there, right there. So I'll write out the formula that I'm going to use. So it's 1 plus R over PPY over 100. And then the formula says, so that's the R part. And then I'm going to times it by VO. So let's go through. Now, do we know what VO is? That's what PV. PV is always VO. Now, do I know what the little r is? I do, don't I? It's 3%. And what was PPY? Was 4, wasn't it? Because it's compounding quarterly. Over 100 times 5,000. Okay, so you look there, they've all got the 5,000. So all of them have this. This is the R bit, that R. So all of them have a different R. Now, when you're investing, you should be growing, and we can see it's 1 plus. So I could quickly eliminate these silly ones that don't even have a 1 there. So that you could get them out of your system so you don't accidentally pick them. But what we're going to do is type this bit into the calculator, and this on our calculator, we get 1.0075 times 5,000. So which one's showing this rule? Now, you can see how it says to the power of n, so that's actually to the power of n. So which rule is it? It's this one. This guy here, D. Actually. This is, they want the rule for nth years. So we better write this. So this is the formula. We have just found the formula for the nth term of the periods for. This is for quarterly, yeah, because our rule was for quarterly. So times 5,000. Because they asked us after n years, there's 4 quarters in a year.
In order to get 1 year.
So we'd have to put 4 there. So that's why this is E. Okay, the nominal interest rate for the loan is 8% per annum. When they say nominal, that just means like what the bank quotes. So on Finance Solver, the I, like the normal per annum rate, okay? When rounded to 2 decimal places, the effective interest rate for this loan is not, okay? So we've got a few we're going to have to check. So in this first one, they want it daily. So I'd go EFF, I'd do the 8. Now, how many days per year? We're just going to say 365, okay? So, and what do we get when we do that? So I get that. So this one is correct. Yeah, so it's not incorrect. So we'll do the next one. EFF, 8%. And what's it going to be, comma, if it's weekly? 52. So we'll do that. Okay, 8.32. So this one is correct. So not the answer. EFF, 8, comma, fortnightly is 26. What do we get? Do we get that? 26. I get 8.32. Oh, so that's not right, because if you write this, round this one we get 8.32. They're saying it's 8.31. 31. Yeah, so we got this one to be, if we went ahead, that was 8.24, so that was correct. So we found that this one was wrong, so we're going with that. Now, when you're in your exam, just make sure you would have probably worked from there downwards, okay? So once you get on C, you found it's wrong, move on. What you should do though is asterisk that and check those two when you go back to check your work, because then you're checking something different. And if that proves you right, then you're right, generally. If that proves something's gone wrong, let's have a re-look at that question. Question 29. The value of a van purchased for 45 depreciates by K% per annum using the reducing balance method. So we've got that, we've been told. After 3 years this depreciation, it then depreciated in the 4th year under the unit cost method. So it changes after a while. The value of the van after it travels 30,000 kilometres in the 4th year is this, okay? So find the value of K. All right, so what we need to do is, all right, so what we're going to do is we need to find this, we're going to use the unit cost. We're going to go backwards, okay? So if we go and get the unit cost formulas, just in case you need a little bit of help here. Okay, so I've applied that, done. Okay, so if you look at the unit cost, we know, what they've told, we can work out this D, how much it appreciated. So it only does the unit cost for 1 year, yeah, because it says in the 4th year. So it says it travels for 30 kilometres. So if you look at the amount of depreciation, it's travelled 30 kilometres at 15 cents per kilometre, okay? So if you look at that value, whatever that is, so I worked out that is 4,500. So what you know there is in the 4th year, it depreciated by this amount. So if I add that 4,000 to this price, that's going to tell me what the value was at the end of 3 years, yeah? So if I do 26166.24 and I add the 4,500, that will take me back to the end of the 3 years. Okay, so if I do that, what's that? So I get the 30666.20. Oh, sorry, it should be 24. Okay. All right, so now I know that is the end of the reducing balance. So now we probably want to move into using the reducing balance method. So let's go find the reducing balance formula now, which is here. I'm going to use these. Okay, so if you look, I actually have, this is like, if I, this is actually like V, the value after the 3 years. So I've got V3. So I might use this nth term formula for depreciation. So I know what V3 is, so I'm going to write that in. I'm going to say so I'm using this. I'm going to say 30,666.24 equals the R. Now I'm using that, it's 1 minus. Now, see how the K per annum up here is what they want to know? In my formula here, that is actually R. Yeah? For us, that's R. So you could write R as the question. So we'll pop that in here. So I've got 1 minus R is my question. Now PPY per annum, it's a reducing balance. So I just said per annum. So PPY is 1. It's actually just going yearly over 100. Now times, do we know what the VO was? What was it originally purchased for? Here, 45,000. Now, see how here I only have the only thing I don't know is the R. So you can pop that into your calculator using solve. Boys, this was VN, so you need the 3 in there as well. Sorry, don't we? Because we know this is V3, yeah? If it's 3, then that has to be 3. So to the power of 3 times the VO, which was 45,000, and I want comma little r, I get 12%. So I get R equals 12, which, okay, 20 years ago, Hector invested a sum of money into his account, earning interest at a rate of 3.2% per annum, compounding monthly. After 10 years, he made a one-off extra payment of $10,000 to the account. For the next 10 years, the account earned interest at 2.8% per annum, compounding monthly. The balance of his account today is this. The sum of money Hector originally invested is closest to. So we need to, obviously this one will be finance solver, and we need to think about what's happening. So 20 years ago, he invested the money. So because we've gone so far, his balance today is this. So we probably want to go backwards, yeah? So let's have a look. We've got for the next 10, so after 10 years, he made this one-off payment. And then for the next 10 years, so he has this scenario. So from here, I'm going to mark it here. I'm going to work from this point first. Okay, so I'm at the second, I'll write the second 10-year slot. Yeah? So let's think about that. We've got, and we want to try and work, so we've got the I, we've got interest rate, we've got compounding monthly, so PPY is 12. We know for 10 years, so it's 10 times 12, we know that amount, and we have a final value, okay? So let's go into finance solver, and let's see what he had to begin with. So we're looking for the PV at this second lot of 10 years. So let's have a look. So we're going to do, we know he went for 10 years at monthly, so 10 times 12. We know the interest rate was 2.8. This PV is what I'm trying to sort of find out. What did he start with? You know, what did he have at that beginning of this second 10 years slot? Now, payments, he's not making any other payments. It's just an investment, so we'll call that 0. And FV, we do know he's going to get this back, so it'll be 686,904.09, and PPY is 12. So let's go do that on the finance solver. So I get a negative, which is what we're saying, which is good because that would be investing into the bank. And I get this, and I'm just going to round it to 3.0. Okay, so this is the beginning of that second year. Now remember, he actually made a one-off extra payment of $10,000. So then I've got to because what I'm going to do is I'm going to move backwards into the first 10-year slot. Okay? And what we're going to do is we are going to have, this will still be 10 years by 12, this new interest rate. We are going to know, we want to know the PV, that is the question. We're going to know what this final value is at the end of that first 10 years. That's what we just found here. But we've got to remember, he put an extra 10 grand into this. So we're going to minus 10 grand out of this guy. Yeah? So, which will tell us, so if I put that in, so what's it going to be? 509,320.30. So is everyone happy with me doing that? Because they told me if he puts 10 grand in, I want to take that out before, yeah, we start. So then we go into here and we pop all that data in. But remember, you're changing your interest rate so remember to change that one to 3.6. PV is what I want to know, and my final value. And it becomes positive as well, because that's a positive, you're getting that back. 509,320.30. So my original PV is, what do you get closest to? I get a negative 355,532. So what are we going to say? Closest to, oh my God, I've got the wrong. Okay. So I'm not sure if I just said that. So we have to, I'm just doing it on the video. We had to take 10,000 off this second year value so that it would match into here. And then when we do this, we get negative, I get like 36,999.99. So it's going to be matching up to this 370,000.